Hi everyone, welcome to my channel TCU for Olympiads and JEE. Today I am back with the one question series and this is 04. This is 04 and this is the physics series. Okay, let's moving on to question number 4 of our series and the only question and the question for today. The position of a particle moving along x-axis depends on time as follows. X is equals to u by k 1 minus e to the power minus or kt, where u and k are constants. We have to find what is the total displacement of the particle and the distance covered by it. This s must be not there. Total displacement of the particle and the distance covered by it. How are the velocities and acceleration related to each other? Pause the video and try the question. I hope you have done that. I am moving on to the solution. The answer is given here. Answer part A is distance covered is equals to displacement covered is equals to u by k, and part B is acceleration at any instant is proportional to the magnitude of velocity and is directed opposite to its velocity. Now let's see how one can solve this question. Part B is simply easy if one can successfully solve the part A. But let's see how we can approach. Let's first of all find the total displacement. Total displacement will be x at Total displacement will be x at infinity minus x at 0. Right? So total displacement is x at infinity and then we will have minus x at 0. Okay. Now in place of t we will simply put the values. Okay, now x at infinity will be u by k 1 minus 1 by e to the power infinity. Is it so? Yeah. So, and then we will minus u by k, then we will subtract here 1 minus 1. This term cancels to be 0. This term goes out to be 0. This term remains, which is equals to u by k. So we got displacement to be equals to u by k. We have done total displacement is completed. Now let's see total distance. How will we find the total distance covered? To find the total distance covered, let's find the first instantaneous velocity. Instantaneous velocity is v is equal to dx by dt. Now on differentiating this, we will have u by k and then here we will have 0. My differentiation of constant is 0. Then we will have minus of minus k, then e to the power x, differentiation is e to the power x only, so here e to the power minus kt. Okay, this seems to be I'm just it's now kt. This becomes, this negative cancels, this k cancels with this. We will finally have this to be equals to u e to the power minus kt. Okay, we have got this. Now here we need to check. Let's first of all draw the graph of this. First let's draw the graph. How will the graph look like? Means I'm drawing the graph here. If this is the time and this is the velocity, time can never be negative, or else graph of e to the power minus x is always like this. But since graph time can never be negative, we will start with at time equals to 0. In time equals to 0, here we will have u. This part is u. Means this part is u. Then we will after all go on up to infinity. That k will just change the graph, but at in frame of infinity that kt will doesn't cause any specific difference. and the graph will look like this only, a rough graph, let's say. Okay, now see, here one observation we need to make, that is the velocity will never be negative at any case, and if the velocity is not negative, then okay, I'm just briefing the part. Velocity is not negative anywhere. Yeah, velocity is positive always. Positive always. Always, yeah. Well, since velocity is always positive, so displacement is equals to distance. This statement, okay. I'm just arrowing this statement. Displacement is equals to distance, and we all know this. We already know distance is equals to u by k, right? I'm just rubbing this part. Yeah. So we solve the part A. Moving on to part B. Moving on to part B. Part B is pretty simple. And the answer is, I'm just repeating it. Okay, I'm just solving it, then we will repeat. In part B, we were told to find the velocity and acceleration relation. We already know V is equals to u into k to the power e to the power minus kt. This is known to us. Now just differentiate this acceleration. Let's differentiate this acceleration with respect to time. We are differentiating, so this will be u into minus of k into e to the power minus kt. So this is equals to minus k into u e to the power minus kt. See, this thing and this thing is same, so we can write this as, this is equals to minus kv. From this statement, we just analyze the fact that acceleration at any instant is proportional to the magnitude of velocity, but is directed opposite to its velocity. And so we have proved this part. With this, we come to an end of this video, end of this question, and the end of this video as well. With this final note of thanks, I am ending the video here. Thank you so very much for watching the video till the end.